Very good morning, children. In this present video, we are going to see about the factors that are affecting the equilibrium. What is the topic we are going to have a glance? Factors affecting the equilibrium. Yes, whenever a system is at equilibrium, means the concentration of reactants is equal to the concentration of products is the point that we had learned. Now imagine we know about the balance. The balance means left side tray and right side tray when they are under a balanced state. Seesaw you will call right. In another example, children will play in the park. See this seesaw, when you bring a change on one side, means if you place some weight, what will the other side will do? The other side will lift above or up. If you bring a small weight in another side, this side will be moving to opposite direction. Means when you bring a change in one side, I am placing some weight, compulsorily this will be affecting the other side. This will be affecting on the another side. This was brought by a scientist called Le Chatelier. Who is the scientist called Le Chatelier? Yes, his explanation is based upon the equilibrium of the system. How is it affected? It is affected by mainly change of three factors. What are those three factors? Means temperature, concentration, and pressure. What are the children? Temperature, concentration, and pressure. So the equilibrium of the system depends upon these three main factors. Means if you bring some change in the concentration on the reactant side, compulsorily there will be effect on towards to the products. One example we shall take. What is the example we shall take? Before we take the example, once let us have a glance on what are the factors affecting the equilibrium. What are the factors you can see here, children? Temperature, pressure, and the concentration. Then what is Le Chatelier principle? We got some definition on the board. Have a glance on the definition. What I pointed out, when we bring a small change on one side of a equilibrium system, there will be a change opposing towards to it. Or we can see the definition. Change in any factor that determines the equilibrium. What are the factors that determine the equilibrium, children? There are three factors that are determining the equilibrium. What are those three factors? Temperature, pressure, and concentration. Means when there is a change in any of the factors that determines the equilibrium conditions of a system, system will cause the system to change in such a manner. Means any change in one of these will cause the system to change in such a manner to reduce or to counteract the effect of change. What the main point? To reduce or counteract the effect of change. Means if you bring a change in one direction, the system will move to another direction. There is a counteract here. Yes, when you bring a change in one direction, there will be a change in the other direction. Let us take one example regarding effect of change of concentration. Effect of change in concentration. See children, we will bring in a general manner, then we shall take one example. In a reaction, what will be there? Reactants will be there, and also products will be there. What will be there? Reactants will be there, and also products will be there. Now, what we are bringing is at equilibrium. At this equilibrium, the concentration of the reactant is equal to the concentration of the product. Everyone knows that, right? Now, at equilibrium, if you increase number of reactants, then where the reaction will move? The reaction will move, or the system will move towards the direction to reduce the change or to oppose the change. Means when number of reactants were increased, Number of reactants were increased. System will move towards product side. Which side, children? Towards products side. When number of reactants are increasing or concentration of this reactants is increasing, system will move towards to the product side. That means it is favoring a forward reaction. Which reaction it is forwarding? A forward reaction. Or in another term, if you increase the concentration of products, system moves towards the product side. Sorry, when the concentration of products means if you increase the concentration of product, system will move towards the opposite direction. Means system will move towards to the reactant side. When the concentration of products increases, system will move towards to reactant side. That is backward reaction takes place. A simple example I would like to give here. What the simplest example means? I am taking hydrogen is reacting with iodine to form hydrogen iodide. Now let us assume these are the concentrations of hydrogen and these are the concentrations of iodine. Concentration of hydrogen iodide at equilibrium. Generally the concentrations will be the same. But what I am doing now, I am increasing the concentration of hydrogen. Then to which direction the system will move, children? This is on the reactant side. Which side is this one? This one is on the reactant side. The next one is on the product side. So what will happen now? When we increase the concentration of the reactant, system will move towards to the product side. Means when we increase the concentration of hydrogen, the number of moles of hydrogen iodide will increase. It favors forward reaction. What will happen if we increase the concentration of iodine, children? If you increase the concentration of iodine, what will happen? It will favor the forward reaction. The same will happen. What will happen if we increase the concentration of hydrogen iodide? If I am increasing the concentration of hydrogen iodide, that is the product side, the system will oppose the change. It will try to move towards to the reactant direction. It favors backward reaction. I hope you understood because the example is very simple example. Let's go down. We will take one more example regarding the concentration. Then let us see the example here in example number 2. What is example number 2? We want some Fe3 plus ions. Or we want some Fe3 plus ions. Actually these Fe3 plus ions are brought from ferric nitrate. These are brought from ferric nitrate. The source is ferric nitrate. SCM minus thiocyanate ion. What is this one called, children? Thiocyanate ion. Actually it is taken from potassium thiocyanate. These are the source. When they are dissolved in water, we want these ions. Which ions? Ferric ions and the thiocyanate ions. When you mix these two, approximately the ferric ions and thiocyanate ions, when we mix with each other, they will bring a red color compound. They will form a red color compound. What do they form, children? They will form a red color compound. But whenever the system is at equilibrium, means when the concentration of the reactants is equal to the concentration of products, there will not be any change. At the equilibrium stage, when you are increasing the concentration of the reactants, where do the system will move? The system will move towards to the forward reaction. Increase in concentration of the reactants, the ferric thiocyanate. Ferric thiocyanate means what? Means what, children? Means when you are increasing the concentration of reactants, which color will become to be increased? The red color will become increased in intensity. The red color intensity will be increasing. Even if we increase the concentration of, thiocyanate ion, increase the thiocyanate ion, then also the formation of thiocyanate, ferric thiocyanate ions will be increasing. Means when you bring a small change on one direction, system will counteract to the another direction. So when we observe with increase in the concentration of reactant, what color will be increasing? Red color intensity will be increasing. But come to the next point. If we increase the concentration of thiocyanate ion, means what you are increasing? You are increasing the concentration of products. What you are increasing, the children? You are increasing the concentration of products. Then system will move towards the backward reaction. System will move towards the backward reaction. Means the red color intensity will be decreasing. So that's what how to say. When you bring a small change in concentration of one direction, system will move towards the opposite direction. Very good. Now next we are going for the effect of pressure. What is the effect of pressure? The effect of pressure, we are having a glance. Whenever the homogeneous equilibrium we are seeing, we are not studying here heterogeneous equilibrium, because there the states of matter will be different, and there is no effect of pressure also. But we are seeing only this one in the homogeneous equilibrium condition. When the number of reactants, which reactants? Gaseous reactants. When the number of gaseous reactants were equal to the number of gaseous products, when the number of gaseous reactants are equal to the number of gaseous products, the system will remain at equilibrium. The system will remain at equilibrium. What is this one, sir? If you know the previous equation, if you recall, hydrogen gas is reacting with iodine gas, to form hydrogen iodide gas. See, in the reactant side, how many number of moles of hydrogen and iodine are there? Here 1 mole of gaseous reactant is there, another mole of gaseous reactant are there. Means in reactants, how many moles of gaseous substances are there? 2 moles of gaseous substances are there. Coming to the products. In the products, how many number of moles of gaseous substances are there? 2 moles of gaseous substances are there. So here they are not grams. This is the gaseous reactants, and these are also 2 moles of the gaseous products are there. Means the number of reactants were equal to the number of products. Number of moles of reactants were equal to the number of moles of the products. At the time there will not be any change at the equilibrium. But if the number of reactants in the gaseous state are more than the number of products present in the gaseous state, then the reaction will be a forward reaction. What is the reaction will be? A forward reaction. Let me take one example regarding this statement. Can you see here carbon monoxide is reacting with hydrogen gas. At equilibrium, it is having methane plus water. What is it having, children? Methane plus water. Now can you see here the reactants? How many number of moles of gaseous reactants are present? Here 1 mole of carbon monoxide is there and 3 moles of hydrogen are there. So gaseous reactants are how many moles, children? Totally 4 moles are there. Do you agree with me? 3 here 1, totally 4 moles are there. And how many products are there? How many products are there? Means what are the number of moles of the gaseous products? Here 1 mole, here 1 mole, here another mole. Only gaseous products are 2 moles. Then if we increase the concentration of carbon monoxide or if we increase the concentration of hydrogen gas, means when the number of reactants moles are increasing, then the reaction will move or the system will move towards to reduce the opposing change. Means it will favor for a forward reaction. Now in this case also, what type of reaction we will see? We will see a forward reaction. We will see a forward reaction. So the same thing happens in the manufacturing of ammonia. What is that one in the manufacturing of ammonia? Nitrogen gas reacts with hydrogen gas. Hydrogen gas reacts with hydrogen gas to form ammonia. To form ammonia. Here how many moles of nitrogen are there? 1 mole is there. How many moles of hydrogen are there? 3 moles are there. So totally how many moles of reactants are there? 4 moles are there. But here only there are 2 moles. So this is also favoring towards a forward reaction. Means if you increase the number of gaseous reactants, pressure will be increasing. It will shift towards to the product side. So we understood what is the effect of pressure. Means when the number of reactants, gaseous reactants are more, it will favor for a forward reaction. I hope the point is clear for you. Now let us go with what will happen with the change in temperature. We are seeing change in concentration, we are seeing change in pressure, we are seeing change in temperature. Right, all the points there is a change in temperature. Let us continue here tonight about the remaining 2 concepts. What are the 2 concepts we are having? What is the effect of inert gas? We didn't raise this point when we are writing, but we want to highlight this point. What is the effect of inert gas at constant volume? Wherever the volume is constant, if you are bringing any inert gas either on the reactant side or on the product side, does that will have any effect? No, there will not be any effect on bringing any inert gas. For example, you want to add argon into the reaction. Argon is an inert gas. So whether you add it on the reactant side direction or product side direction, it cannot bring any change because it will not have any pressure, partial pressure. So inert gas does not change the partial pressure or the molar concentration of substance at constant volume. So there will not be any change for the equilibrium by adding any inert gas, because that cannot bring any change in the partial pressure or it cannot bring any change in the concentrations, because those are inert. It does not participate in the reaction. So what is the effect of change in temperature? Do we know that endothermic reactions are there and exothermic reactions are there? What are endothermic reactions? The reactions that takes place by absorbing heat. Most of the decomposition reactions are endothermic reactions only. How do we know that it is an exothermic reaction or endothermic reaction? Until and unless beside the reaction, means right side to the reaction. Let us see one reaction here. 2 moles of NO2 are giving rise to N2O4. Some delta H value they will say it is equal to minus 57.2 kilojoules was given in this reaction. Once again, 2 moles of NO2 are giving rise to N2O4. Delta H value is given as minus 57.2 kilojoule moles. By seeing this delta H value, we can say whether that is an endothermic reaction or exothermic reaction. When we have the delta H value, means change in enthalpy is negative, means heat is released to the surroundings. When do heat will be released to the surroundings? When the reaction is an exothermic reaction, then only heat will be released to the surroundings. So by seeing this delta H value, we can determine whether it is endothermic or exothermic. Now endothermic reactions, delta H will be positive, right? For exothermic, delta H will be negative. Now generally for endothermic reactions, they want heat. So if we increase the temperature, the reaction will move towards to the product's direction. Once again I am repeating, for the endothermic reactions, with increase in temperature, the reaction will move towards to the product's direction. And for exothermic reactions, already heat is being released. So what will happen? If we increase the temperature, they will forward or they will reverse the reaction. Means from product side it will come back to the reactant side. So endothermic reactions, generally delta H is positive. So when you increase the temperature, as they want the temperature, it favors for a forward reaction. Exothermic reactions means when delta H is negative, favors a backward reaction. Now what kind of reaction is this one? Is this a forward reaction or backward reaction with change in temperature, children? Yeah, this is a backward reaction, because for endothermic reactions, if you increase the temperature. It will be reversing the reaction. So I hope you understood. For observing endothermic or exothermic, you need to see the negative or positive side. Then what is the effect of catalyst? Generally, catalyst does not have any effect at the equilibrium. But the catalyst, what it will do, it will decrease the activation energy. Means it will increase either rate of forward reaction or rate of backward reaction. So what we are saying, what is the effect of the catalyst on equilibrium means there is no effect of catalyst on position of the equilibrium. It shortens the time to attain the equilibrium quickly by increasing the rate of forward reaction or backward reaction by decreasing the activation energy. That's it. There is no effect of catalyst. The point we want to write. So in this class we have learned many things. Have a nice day. Thank you. In the next session we will start ionic equilibrium. Thank you, children.